right, so let's review for that final. So it's cumulative, meaning you've got everything, including the easy stuff right here. Just a basic linear equation. So distribute and solve. So just make sure you apply the distributive property, then combine your like terms. It'll be good. On the left side, I got 5x minus 6x is negative x. Negative 5, positive 12 is a positive 7. On the right side, I just got 6x. And I've got negative 28 over here. I'm going to add x to both sides. Add 28 to both sides. 35 is 7x. Divide by 7, and you get 5 is equal to x. That's it, just a basic linear equation, guys. 3 points. Yes, work is required. Next up, we have a quadratic. Okay, so this one not quite in standard form. Let's get it there first. I'm going to go ahead and add 2x squared both sides. You could get the other stuff to the left side if you wanted. Doesn't matter to me, as long as you have a 0 somewhere. 2x squared minus 20x plus 46. And it's equal to 0, so I'm going to go ahead. It's a quadratic. Mode 5, 3. And I have a positive 2, negative 20, and positive 46. If you went the other way around, you just have the negatives of those. 5 plus square root of 2, 5 minus square root of 2. That's my answers. You can do plus or minus if you want. Nothing much on there. I will let you use one of my calculators for your final, so don't fret. Make sure you know how to use it too. Another quadratic. It's got a whole bunch of word problem, blah, blah, blah. How many seconds will it take for the ball to reach the ground? How high off the ground is the ground? 0. So that means S is 0. 1 second, please. All right, so 0, that's the ground. 0 equals negative 16 t squared plus 48t plus 288. Oh, hey, look, it's another quadratic. It's in standard form. Type it in the calculator. Yes, literally, that's all you have to do. Negative 16, 48, 288. Once you get it in standard form, it's quadratic, just type it in and I'm good. 6 and negative 3. So t equals 6, t equals negative 3. This is an application problem, so make sense of it. T is seconds. Does it make sense that the time would be negative? No, it does not. T equals 6 is our only logical solution then. Oh, no, what are we going to do? It's got i's in it. Oh, yeah, we go to mode 2. And then we type it in. 3 minus 2. There you go. Look, where's the I? Where's the I? Oh, there it is. 5 minus 3. Where is it? Right there, right above 8. See it? You just have to hit it. And we get that. 21/34 minus 1/34 I. I'm going to write I over 34. Right, 1/34 I for sure. Doesn't matter. But this is standard form. That's all you have to do. Okay, now this one we actually have to do some work. It's a radical equation, so to solve it, we raise both sides to the index. That's going to give us 4x plus 13 on the left side. And that's a binomial, so write it out. I do expect work. Now, you don't have to show this step, but if you don't show this step, I bet you're going to mess it up, so show the step. 4x squared minus 2x minus 2x plus 1 That's 4x plus 13. Not going to touch that. I'm going to combine like terms over here. X plus 1. We have a quadratic again. So I'm going to take this stuff on the left side and bring it over to the right. 0 equals, must be x squareds. I got negative 8x's. And negative 12 is my constant. Type it in. 5, 3, 4, negative 8, negative 12. And we get 3 and negative 1. Now remember, it's a radical equation, so we always have to check for extraneous roots. If I plug in negative 1 into here, I know that's not going to work, so I get negative over here on the right side. If I plug in 3, 6 minus 1 is 5, 12 plus 13 is 25, squared that is 5, so 3 checks out. Let's take a look at this one. It's a absolute value, or sorry, it's a linear inequality. So solve it just like you do an equation. Combine like terms, go ahead and do that. 5x plus 2, less than or equal to distribute that 2. The x is on one side, the constant's on the other. Divide through, and remember the only thing we have to worry about whenever we're dealing with these is whether or not we divide or multiply by a negative. If we do, we change the direction on the inequality. We did not, though, so x is less than or equal to 4. Done. Not done, it says graphic. So put yourself a number line. Here's a 0. Here's a 4. It's solid, so it's going to include it, meaning you can put either a bracket or a solid dot and shade it. Now the answer needs to be in interval notation, so bracket 4, comma, infinity. So this is the answer. That's the graph. Make sure you put your answer in interval notation. Now we have an absolute value inequality. And you have to read this. What symbol is that? Well, what symbol is that? No, that's a less than. And so you're going to make a sandwich out of it. If it was an or, you just split it up. If you do one side, you do all 3 sides. So subtract 4. By 2. And that's my answer. It does not include it, so I'm going to put it in parentheses. Interval notation, and done. It says graph the thing, so again, I'll have the number line provided for you, don't worry. Here's a negative 5, here's 0, here's 1. Don't you love my spacing? So you can either put open dots, or you can put parentheses, and you'd shade in between. Usually put the open dots on the graph. Let's just work too. Synthetic division, lovely. Shouldn't take but a second. If we're dividing by x minus 3, what makes that 0? A positive 3. That's what's going in the box. Write down your coefficients and make sure you write down all of them. I have 7x cubes, negative 16x squareds, 0 x's, and 7 for my constant. Bring down the first number, multiply and combine, multiply and combine, multiply and combine. So that's my remainder. My answer, reduce this by 1, is going to be a quadratic. 7x squared plus 5x plus 15 plus our remainder over our divisor. That's it there. That's the answer. Domain and range of this thing. It doesn't ask for much. There's nothing to solve. You just say, hey, domain, I know this thing's got to be greater than or equal to 0. I kind of left off half the equation there. the inside part of this radical must be greater than or equal to 0. Let's solve it. 3x is greater than or equal to -9. X is greater than or equal to -3. That's my domain. -3 to infinity. My range. Easiest way to do it, think about the radical modular functions. Square root. 0 to infinity is a basic one. We didn't have any vertical shift, so the range is 0 to infinity. If you would have had something out here, a vertical shift, it would have been that to infinity. If you would have reflected it across, if you would have reflected it across the y-axis, it would have been -infinity to 0. So just go with, transformation to your mother function. Easy way to do this one. And range done. Sketch the graph, find its vertex and intercepts. So to do that, I will provide you some graph paper, but for now, let me just do this. Sorry. 1, -6, 11, intercepts. So x-intercepts, those are imaginary, so there's none. Y-intercepts, easy enough, it's just my constant. Vertex is 3, 2. Now let's graph the thing. Let me just go ahead and make some axes. Perfect, but it will be nice on your paper. Don't worry. Something like that. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Yep, no, nothing. Who cares? 9, 10, 11, 12. Sure, something like that will work. Point 3, 2 is my vertex. 3, 2. I got a point 0, 11. 3, 6, 9, 10, 11. And, you can use the symmetric property here. It's 3 faces away, so 3 faces away is going to be right here. Also, you can remember A times odds. A is the coefficient right here, which is 1. So it's just 1 times your odds. 1 times 1, 1 times 3, times 5, etc. We're going to go from a vertex, right 1 always, and then up. The first one is 1. Mirror it. From that new dot, go right 1 and up 3. Mirror it. From that next dot, we go right 1 and up 5. Hey, look, it's already there. So there you go. That's the graph. Connect your dots. Make sure it has a nice round bottom there. And yes, I will provide you a graph on your final. All right. So it needed vertex, intercepts, and yeah, so intercepts, no x-intercepts, 0, 11 was y-intercept. We got that by plugging in 0 for x, which means that's gone. And our intercept is 11. Vertex, easiest way to do it, calculator, multiply 3, it tells you. You could also do negative b over 2a. You really want to do some work. negative 6 is positive 6 over 2 times 1 is 2, so that's 6 over 2 is 3. Plug that in here to get the 2. I don't know why you'd want to do work, but that's how you do it. Composition, oh no, wait, sorry. F plus g of -4. Okay, super quick and easy. F of -4 is what? G of -4 is what? We're plugging it in we're plugging a number in here, so it's super easy. Just evaluate each one. Plug it in, that's 16 minus 2 is 14. That's in a second. -12 plus 3 is -9. Then we're going to add that together. 14 plus -9, that's 5. Done. Now composition. This has got an x in it, so we're not just plugging numbers. Remember, we're going right to left. G of x is going to go into f. So this is going in right there. So write out f. Instead of x, open his mouth up, big old set of parentheses. What's it eating? The other function. That's all composition that is. It's one function eating another. Distribute, combine like terms, simplify, blah, blah, blah. Do it. 4x minus 4 plus 4. Is that just x? That is just x, okay. That's the square root of 4x. Now this is probably a bit of a trick. That's the square root of 4 times the square root of x, right? So that is 2x. Yeah, 2 square root of x. Not that true. Yeah, that's all you gotta do there. Find all the zeros if we know that is a 0. That means we got to solve this thing. It's a cubic. Do we know how to solve a cubic? No. Oh no, what are we going to do? Well, we know one of the answers. So we're going to use that to make it a quadratic. And then we can use a quadratic formula, multiply 3 on that. It gives us k. So we're going to use that. Write down your coefficients, make sure not to skip any. Now, when we do the work here, it better have a 0 at the end for remainder, otherwise we screwed up. -15, -11, 55, -4, +20. Yep, that's a 0. So this becomes 3x squared minus 11x minus 4. That's a quadratic. Shove it in. Move 5, 3. 3. -11. -4. 4 and -1/3. We got those 2 zeros from here. We also have that -5 and 0, so don't forget to write it. Find all zeros. So this is all of our zeros. Make sure you indicate that -5 is also 0. It's pretty. Don't lose it. Factor it. Negative division again. So this time we're actually going to have to factor the damn thing. 2, -3, -11, 6. So 2x squared plus 3x minus 2. You have options. You can do the AC method, or you can just shove it in the calculator and work backwards from your answers. But always make sure you check for a GCF first. Before you do anything else, check for GCF. No GCF. I'm going to just go ahead and use the AC method because it's really quick and easy. Be a +4 and a -1. Put those over A. Simplify. So I've got This is my coefficient. 1x plus 2, 2x minus 1. Done. That's this factor, right? What about this piece right here? K equals 3, x minus 3 is our factor, right? So don't forget that one. I'm going to shove it out front or in the back or in the middle. Doesn't really matter. Just shove it in there. And there we go. That is factored form. Make sure you put that original in there for both the zeros and the factored form. Otherwise, you will lose points that are free. Don't lose free points. They're the best kind. Okay, now this one, it's a quartic, fourth degree. We don't have a thing to solve that, so yeah, let's go ahead and do the AC method. Yes, you could use the quadratic formula, fine, but make sure you know what to put. No, sorry, 5. So factors of negative 36, that add up to 5. How about 9 and 4 with the 4 being negative? Put those over A. Simplify. Now, remember, it's always this guy right here that is our variable. So that's 1x squared plus 3 and 3x squared minus 4. 1 second, please. All right, so yeah, sorry. We got it factored. Let's solve the thing. Remember, to solve it, we set each term equal to 0. Now, it doesn't specify over the real, so imaginary solutions are perfectly fine. Notice neither of these have an x term, so we don't need to use mode 5.3 on these. You could. It would work just fine with 0 for the x term, but it's easier than that. Just do some basic algebra. Subtract to isolate the x squared, and then square root both sides, not forgetting your plus or minus. So x equals plus or minus. What's the square root of negative 3? Well, that's the square root of 3. I. Make sure your I is not underneath the radical. And then over here, same sort of thing. Oops, sorry. Or again, you could do mode 5.3. That'll work just fine. Divide. Now you're welcome to do this by hand or type in a calculator. What is that? 2 square root of 3 over 3. Yeah, 2 square root of 3 over 3. Oh, sorry. Square root both sides. X equals, don't forget your plus or minus. So plus or minus 2 square root of 3 over 3. Two more. We can do it. All right, we got a couple to do. Okay. A rational equation. So remember how to solve these. Find your GCD. Let's do it. So first you're gonna look, can I factor anything? I can factor this thing. What's the difference of squares? Oh, hey, that's nice. This is my GCD, isn't it? GCF, sorry. Greatest common denominator, greatest common factor. Yeah, whatever. Greatest common denominator here. That's what we're looking for. LCD, least common denominator. Too many G's and L's, whatever. Find the thing that all these things can go into. LCD. Here, we're going to go with that. Least common denominator. X minus 2, x plus 2. This is covered. This is covered. This is covered. We're good. Multiply each and every term by your LCD. Yes, write it out. x minus 2, x plus 2 times 5 over x minus 2 minus x minus 2, x plus 2, 2 over x plus 2 equals x minus 2, x plus 2 times 3 over x minus 2, x plus 2. Good idea to leave this in factored form whenever you do it, because cancel, 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 cancel. Let's just write out what we're left with so we don't get confused. 5 times x plus 2. I like writing my constants out front and the binomials in the back. Minus x minus 2 times 2. So I'm going to do minus 2 times x minus 2. Again, you could write it either way you want. It doesn't matter to me, but that's how I like to write it. Oh, hey, look, now it looks very similar to problem number 1. 5x plus 10 minus 2x plus 4 equals 3. 3x plus 12 equals 3. X is negative 9. X is negative 3. Always go back and check and make sure this is in your domain. Can I use a 3 and negative 3? Yeah, I can't use 2 or negative 2, but negative 3, perfectly fine. Yeah. Okay. Let's take a step back because I can't add. 10 plus 4 is 12. No, it's not. No, it's definitely not. Sorry. Last time I checked, 10 plus 4 is 14. And I did it. I must have did it on my head wrong. Okay, let's just. What's going on with me today? 10 plus 4 is 14. And we're going to do 3 minus 14. It's negative 11. So we have negative 11 thirds. Okay. Should I mess up anywhere else? Okay, that should be it. Assuming I didn't screw up somewhere else. Yeah, negative 11 thirds is perfectly fine. It's not 2 or negative 2, so we're good. Last one. Another radical equation. Notice they're both cube roots. So let's get one on one side and the other on the other side. And then we can just cube both sides. All right. Cube both sides and, well, they just skedaddle. 8x squared plus 13x minus 24 equals 9x. It's quadratic, make it equal 0. And then do mode 5-3. 8, 4, negative 24. 3 halves and negative 2. Oh no, can we not have a negative under the radical? Yes, we can have negatives under the cube root. Since it's an odd index. For an even index, we cross out negative 2 immediately. It's always best to check. But, let's see. 8 negative 2 squared plus 13 times negative 2 minus 24, negative 18. 9 times negative 2, negative 18. That one checks out. Even indexes, no negatives under the radical. Odd indexes, perfectly fine. Let's try out this 3/2, see if it works. So if I plug in 3/2, get 27/2 over here. 9 times 3/2, 27/2, cube root of those, boom, done. The end. That's the final exam review, people. We're all good. Good luck, practice, study, don't fail. I'll see you next year.